Hello everyone. Good afternoon, good evening, and good morning to wherever you are. And I welcome you all to this webinar June edition of 2022. Automotive sector, spearheading the topic, is Axial Motor, the future of e-mobility. On behalf of Saraca Solutions, let me introduce you to myself. I'm lead marketing at Saraca, spearheading the marketing efforts here, and today's host. With me, I have Mr. Syed Abdul Rashid, with about 20 years of experience in automotive, and he is going to help us with information and also ask some insightful questions to our today's speaker. Our guest speaker of today needs no introduction. Manikandan has been known for a couple of patents in EV, belongs to City, and in India, Manikandan is one of the genius minds that we are proud about, founder of Greener Mobility Solutions, has headed technology solutions and highest head designation of founder, ex-CTO of Hero Electric, Hero Electro, Ola Mobility Solutions, and has had a long-term working terms with Bosch. Today, I offer you to hear from Mr. Manikandan. As the topic suggests, this is a short specialized webinar on Axial Flux Motor. So over to you, Manikandan, sir. Also, I would like to say all the participants will be muted during the session. So if you have any questions, you can certainly raise your hand in the ribbon given below and comment your question in the chat box. And I would certainly ask this question to our speaker or to me or to Syed. And with that, I hand it over to you. Welcome today, Manikandan, sir. Good evening.
So very good evening, one and all. I'm not able to start my video. It's some problem probably. But nevertheless, of course, we will start with the conversation. Parallelly, I will try if I can start the video again. Or should I go back and go out and come back? I mean, Deepika, what do you suggest? Should I leave and rejoin? Or does it work?
I suggest you can certainly continue. We would go through the presentation. And in the meanwhile, I'll certainly see if you're able to turn on the video.
Understood. So that sounds great. So I will get into the presentation. So the question in front of us today is the future of e-mobility. Before getting into that topic, I would like to thank the organizers of Saraca, both Mr. Syed and Ms. Deepika, who has given me this opportunity to interact with the whole team here. So what we are going to look at is how this axial flex motor is going to transform the industry, altogether. Already disrupted industry. Electric vehicle industry is definitely going through a major change today. And this disruption has got a lot of offerings in terms of opportunity. That is what I'm going to touch. And also I'm going to tell you about this specific opportunity that axial flex motor is going to give us. So I have prepared an agenda in the following way. What is that OEM's way of looking at a choice of the propulsion system moving forward when we transform into electric mobility. And secondly, what are the trends in terms of electric propulsion system or powertrain systems, including the choices of the motors, and then deep diving into these understanding, and then focusing on the axial flex motor. That is the topic of discussion today. Probably give you some basic working principle of this motor, and also if we can discuss in detail why this motor is different and how it is different from other form of propulsion system. And then we will also get into the insights of analyzing how and what are the benefits that we get if we can move to axial flex motor, as a propulsion system for the future mobility, and we can make some summary out of the discussion. So I would like more of a discussion rather than a monologue lecture delivery. So that's why I also seek the help of Mr. Syed and Ms. Deepika to support me in making it more interactive. Also, the audience, if you want, ask some questions, you can ask me any point of time. So moving forward, I would like to, Deepika to run through the quiz, basically to have an understanding of the audience on EV. So over to you, Deepika. You can just go through.
Thank you so much for that wonderful introduction and taking us through today's agenda. So I am disabling everybody's audio to ensure audio quality. So to participate in this quiz, it is a very simple quiz where we are going to ask you whether the car that you see on the screen is EV or non-EV. So you can comment yes for EV and no for not an EV. And let's start. So first car, please. Okay, I think this is going to be easy. So a Mercedes-Benz 250e. So do you think this is an EV? Yes or a no? Can we please have some quick chat? And you can comment from the chat box here. So Tushar says no, Harsha says no, Navneet says no, Anirban says no. Well, that seems interesting. So Manikandan sir, what's the answer to that? Is that an EV, yes or a no?
Yeah, it goes without saying, it's a 250E. Yeah, E stands for electric, right? This is one of the earliest electric vehicles that Mercedes have produced. I have driven this in North America. See, a couple of my friends uses this particular product, and this has been around in the market for quite some time. Yes, it's an electric vehicle.
Well, that is correct. So it is an EV car. So I would request the attendees now to, let's see, MGZS EV. Well, this one's definitely gonna be easy. So is this an EV, yes or no? So the audience says yes. Well, I must say this is an easy one because the car itself says EV on the tag. Can we please move on to the next slide? This is going to be interesting. Hyundai Venue has been on Indian roads for quite some time. Is this an EV? Well, most of us say no, and I must agree it is not an EV. Let's move on to the next car and see if our audience knows this one. Nissan Leaf. Is this car an EV? Kamlesh says yes, Ajay says yes, Navneet says yes, Chandra Mohan says yes, Anirban says yes, and yes, you all are absolutely correct. This is an EV. Let's check another car.
So one of the, not only that, is one of the mainstream EVs, the very first mainstream EV produced in the world ever, even before Tesla. That's the message here.
That is very interesting, even before Tesla. And here comes a Tesla Model 3. So is this an EV? So Tushar says yes. Ajay says yes, Vishal says yes, Anirban says yes. Well, I must say you all are correct and this must be an easy one. Let's move on to the next car. Maruti Suzuki Ciaz. Is this an EV? Ajay says no. Chandra Mohan says no. Vishal says this is hybrid. Hardik says no.
So Deepika, I will go with Vishal's option. It is a hybrid. So it's a combination of ICE and an electric engine together. That's right. It is a hybrid vehicle. So hybrid vehicle also, existing today in the EV transition. Yeah, this is what I want to convey.
That's great. So this is an hybrid model. And to the ones who said no, a hybrid is the correct answer here. So let's move on to the next car and see if we get this right. Mahindra XUV 700. Is this an EV? So most of us say and agree with this that no, it's not an EV. With that, let's go to the next car and understand if that's an EV. Ajay says in future it will be an EV. That is interesting, Ajay. Toyota Camry. Well, let me see who can answer this one. Toyota Camry, is this an EV? All of us are saying no. So over to you, Manikandan. Is this not an EV?
It is hybrid again. So the recent generation Camry, it all comes with hybrid engine only option, and is quite popular also in Indian market. So Toyota believes in this, this two-step concept. They want to move all the vehicle to hybrid and then eventually make complete electric. That's the reason they made Camry, which is one of the popular brand of Toyota, into hybrid now.
That's interesting and understood. Well, this has been insightful, and that's a Tesla Model S. I guess our participants already know the answer. So, is this an EV? We all definitely agree that yes, it's an EV. Kia Seltos, a car which has been on the Indian roads for quite some time. Kia has been a very developing brand. So Navneet says, no, it's not an EV. Ajay says, no, it's not an EV. Anirban says it's hybrid. Hardik says, no, it's not an EV. So Manikandan, what's the answer to this one?
It is not. Yeah, I go with an answer definitely. But Kia is also has an electric vehicle, so it is already there in the market, right? So, but they are also coming with the EV6, which is really a luxury EV that is going to compete against the Teslas and the BMWs, and that's an interesting story. It started by Kia in India recently.
Let's move on to our next and the final car, Tata Nexon. Is this an EV? Kamlesh says yes, Harsha says yes, Ajay says yes, Abhishek says yes. Anirban says yes, some models. Now that is interesting. Manikandan, would you like to highlight what's the correct answer?
The correct answer is Nexon. This is not EV, of course. This particular picture which you are showing is on the screen, but Nexon has an EV model. Nexon has all the options: petrol, diesel, and EV together, and that is one of the top-selling electric passenger car in India as on today.
That's great. So I must say we have got a learned audience here. With that, over to you, Manikandan sir, to take us through what exactly is trending in the motors today in 2022.
Thank you, the audience, because basically this quiz was to check how much informed we are about the recent developments in the electric vehicle industry. So fairly, everybody has scored very well, I would say. We are more knowledgeable than what I originally thought. So let us get deep inside these vehicles and what is the electric vehicles are driven, and what are the propulsion system used in these EVs, and what are the options, and how they are functioning, and definitely where do they available or manufactured, how the technology is developed, and this is what we are getting into the details. Some of the vehicles we've already seen in this portfolio that we have shown you. Let's say, for example, Nissan Leaf uses certain type of motors, whereas the Tesla uses different type of motor. So that is how they differentiate with respect to their propulsion options, right? So, but getting into the details, and we will see who is using what and why these different type of motors being used. What are the motors currently available in terms of the different technological aspects available in the market are classified majorly into these categories. To start with, the BLDC motor, I would say it is one of the simplest form of EV motor which is being used, and it is easy to construct And this is also magnet based, but the content of the magnet is very less, and it gives a minimum efficiency of roughly about 80 to 85%. And one of the earliest EVs, produced in the on the mainstream market, it's a Prius, Toyota Prius, come out with the electric hybrid, and they used a BLDC motor as a propulsion system. So it's easier, but it's got a magnetic content. What is the better option when compared to BLDC? Probably induction machine. It was being used by Tesla, but induction machine, the advantage is the power to weight ratio, and the kilowatt per kilogram is really high, and that's the reason why the vehicle, the machine also weighs really higher than the BLDC motor. That was the only shortcoming in terms of induction machine. Otherwise, induction machine is 100 years old technology and very easy to manufacture and easy to control, and also cost is very less. But when we looked at an equivalent motor with a combination of, let's say, people wanted to have a combination of this efficiency of BLDC, lightweight, at the same time magnet free. Then they came out with a concept called SRM motor. It's called switch reluctance, but it works on reluctance principle. But again, the problem with the switch reluctance motor is at a higher speed, efficiency is high, and when the speed becomes lower, and the efficiency also falls. That means it becomes a relative efficiency with respect to speed, and also the torque ripple at a lower speed is very high. So this is one of the shortcomings in SRM motors, but some of the EV manufacturers are still using SRM motor application, like for example three-wheeler, where you don't have a problem with respect to NVH. You can definitely opt for a SRM motor. But to improve or reduce the torque ripple, there is an option to do that. That is what some of the OEMs are following. OEMs like BMW and Tesla in recent times, they have taken SRM motor and added a factor of element of magnet content into it, and they created a synchronous reluctance machine. And this is one of the very popular machines used for EV applications currently, and this also gives enough high torque at the entire speed range. So this is also widely used. Um, but again, considering the power to weight ratio and overall efficiency, again, there is another option available in the market is permanent magnet synchronous machine, both surface mounted and interior permanent magnets. So these machines replaces other machines in terms of the overall torque speed characteristics, overall power to weight ratio, and the controllability. In all areas, this machine is performs better than the other machine, and this is also one of the options available for the OEMs today, right? So these are the currently available and most widely used electrical machines for EV application, and it is based on the vehicle OEMs, based on the kind of application and based on the vehicle, they choose one among these motors for their applications, right? So whether it is is it meeting all the requirements, or where are all the shortcomings, and how do we improve the overall situation in terms of improving the performance, efficiency, and the cost to power to weight ratio and cost, right? And we have to move towards a more optimized solution in the future, and that is the kind of requirement that the OEMs are coming out with. And there is where we have to find a machine which has the best characteristic of all the motors that listed here, and still able to produce at a lower cost. And that is what, my friends, I'm saying is Axial Flex is one of those machines which is got the best of every motor that listed here. So we are going to see the Axial Flex motor in detail in the coming slides. So I have a video for you. Probably I will close this and I'll start this video. Uh,
While we are playing the video, I would also introduce you to Mr. Syed Abdul Rashid, who is asking questions to Manikandan. So, Syed, do you have any questions that you want to ask Manikandan till here?
Yes, uh, one question I have in my mind is that I believe induction motor has been in the industry, as you said, has been in industry for quite some time.
Yeah.
If you look at the torque to weight ratio in this, when compared to BLDC to induction motor, which do you think is actually the best?
Torque to come again. Torque
To
to
weight
weight
ratio.
ratio.
Yes.
Torque to weight ratio. Torque to weight ratio in the overall categories, I would say permanent magnet synchronous machine are the best ones when compared to any other motors.
Okay. And the as far as the weight is concerned, I believe the BLDC will be the lowest, or is it going to be axial motor?
If you have to compare between BLDC and axial, I would say axial would be lower. The way you are going to construct axial flex motor, you can really produce more power and torque in a shorter frame. So in that sense, yeah, right now without you consider without axial, definitely BLDC is the lowest in terms of weight.
Definitely yes. So we were actually about to see the working principle behind axial motors, and I'm going to share the video with you. I believe it's a 6 minutes video.
Aviation, because they have a high torque to weight ratio, which is ideal for aircraft. Companies like Rolls-Royce and Magnex have intense research and development in progress on these motors. Interestingly, the first ever electrical generator developed by the genius Michael Faraday was an axial flux type. You can see the axis of rotation is parallel to flux lines. However, it never got its day in the sun back then. Based on the orientation of magnetic flux, electric machines.
So guys, of course, you have gone through a very interesting video about axial flex motor. You know that the advantage of axial flex motor is in terms of its increased flux density in a limited area, right? So because of this principle, that you can produce larger flux density in a smaller volume of the machine. You can increase the overall torque and overall efficiency of the electrical machine. Deep dive into how it is going to differentiate. Let us say, assume a situation where most of the OEMs are moving towards the electric vehicle, right? And in the past we had all these the vehicle purchases are based on the vehicle performance. For example, I buy a BMW for its engine performance or the engine noise that this vehicle is giving. I buy a Mercedes Benz for the best overall performance and comfort and safety it provides, right? When we move to electric vehicle, for example, at the same power level, every electrical machine is going to give you the same feeling of drivability, performance, and the efficiency. So, how do we differentiate with respect to the individual vehicles when compared to electric vehicle, right? And there is where there is a big gap, and the OEMs are in a dilemma on how do they position their product into the market. So that is where my friends, I feel that the in terms of moving forward, we are looking at more and more optimized performance, optimized improvements in terms of efficiency and throughput, and we have to look at creating some differentiation. And in terms of even e-machine design, as a designer, So I feel that this axial flex motor is going to offer you a complete range of capabilities by which you can create a unique differentiation with respect to the vehicle. So what we based on that, definitely I would we would recommend axial flex motor. But what is very important factor to look at this motor design? The most important thing is the acceleration. So we have to look at how quickly you can accelerate your vehicle from 0 to 100, for example, when you press the act button. So acceleration plays a very important role in the vehicle. And second, most important is the power density. When you have to have high acceleration, definitely the vehicle have to have huge power. Okay, when you have to have package that huge power and how much volume and the weight that you are going to use that use in the machine. So the power to weight ratio, we call power density, that comes next, very important criteria in terms of vehicle manufacturing. And the third important point is the maximum torque, because as a vehicle manufacturer, you have to look at the maneuverability, the drivability, and the gradability, and the load carrying capability of the vehicle. So it needs a maximum torque and how much torque it can produce in the given power and given weight of the electrical machine. That comes the third important parameter. And fourth important parameter, of course, in the electric vehicle, it is NVH. So the noises of electric machines is kind of roughly about 60 dB, that you know that very well, right? So if the noise is, it produces a unique noise, which is kind of an irritating that gets into the cabin of the vehicle. So that has to be, minimized or reduced. So when you look at these parameters, and these are the four areas that we have to deeply look at when we design an electrical machine, right? Yeah. So now you see the spider chart, which I put it in the right side. Looking at the spider chart, and we have also categorized these way the each of the electrical machine available in the market in different values. So acceleration is being one area, parameters. Dynamic response is another parameter. Torque ripple, max speed, max torque, speed range, and noise level are the different parameters by which we have compared the electrical machines. So if you look at the chart, you yourself will appreciate that the axial flex motor, it fairly performs very well in every area, be it power density or be it acceleration, be it the torque and max speed that it produces. And every area, this motor is performing better. That means even as a OEM or as an electrical machine designer, I can really create a different unique proposition for different OEM. For example, you would like to develop a vehicle which is focusing on the speed, so I can definitely give a solution for that. Or I want to make sure that my in-cabin noise is less, right? So if you look at the axial flex motor, the NVH level is really good, great, right? Unless a SRM motor or the torque ripple is at the overall the speed range, it is very uniform and smooth. So in every area, if you look at axial flex motor is going to be really performing better when compared to other machines. That's the reason why I'm saying when everybody's the powertrain is going to standardize, and with the only differentiation you can make in terms of the combined efficiency and combined power to weight and acceleration, and the axial flex is the only motor that can give you the kind of performance that we are looking at, right? So another recommendation comes in terms of the over in the way the sorry, overall the motor construction and the controllability and the cost, size, weight, and this kind of power source it can have. So this is another classification that we compared. And if you look at in deep, if you look at the cost comparison, axial flex motor is in fact is the less cost consuming product when compared to any other product. right? But currently, probably the axial flex motor is priced little high, basically because of the technology development cost and also the supply ecosystem, which is not available currently. So because of that, this appears or seems to be a bit more expensive in the current situation, and that's the reason why this machine is not becoming popular currently. But if you look at overall, that if you from the video also you've seen the constructs of the machine, the content of the materials is very minimum in terms of carbon steel or the copper windings or the magnet content. It is relatively very less when compared to any other machine. So because of that, the cost should come down, and this will come down eventually. And in that area also, if you see, your axial flex motor is the best choice when compared with weight, size, and the current capability, torque capability, and also cost capability. So this is what I recommend. And overall, when you look at and overall pros and cons of the axial flex, if I can summarize, I think yeah, science also can help us in terms of magnet control, magnet content, in terms of controllability, in terms of supply chain and adaptation. This is the only problem right now. Otherwise, in terms of the machines, it has got a very good power. It has got excellent thermal capability, and because of its high starting torque, it can definitely give you a very good acceleration, and the noise levels are very low, and power to weight ratio is really uncomparable with any other machine. So because of that, I feel the axial flex motor would be the future powertrain that we should look at, and we should invest all our energy, research, and our effort into. So this is how I would like to summarize. I am looking forward to any discussion, questions, and I invite Syed to really have his point of view on this, and some questions from him.
Thank you, Manikandan. It was really an insight that you have provided to us today. Actually, I have a curiosity to know, like, what is the kind of average, what will be the kind of performance increase that we can expect out of axial switching to any motor to axial motor in terms of percentage?
See, in terms of efficiency, let's say it is, it can go up to 97% of the motor efficiency.
Oh, that's very good. Yeah.
When compared to any other motor, even if you use PMSM, supposed to be the more efficient motor as on today IPM, this cannot go beyond 94%. Okay. In efficiency, axial flex can easily reach up to 97%. That 3% means a lot when in terms of increasing the vehicle range, because electric vehicle range is a very important criteria, right? Every kilometer that you gain is an advantage.
Correct.
So that is because of that it is. And in terms of performance, I would like to note only one point: the kind of flex density the axial flex motor is going to have, which you have already seen in the video. And because of that, the torque built up in the motor, it is also high, and it is also uniform across the speed range. So you can expect a high torque. That means overall the vehicle performance, be it acceleration or be it gradability, the performance of the vehicle is going to be much better when compared to any other motor which is available in the market.
Okay, I just want to check with you one more thing, Manikandan, is that do you think that the axial flux motor will be always an in-wheel motor, or is there a chance that it may get into another form as well?
It's a wrong notion. It is not an industry. Most of these electric two-wheelers which are popular across the globe, for example, Zero, they are using axial flux motor. In motorcycles, definitely axial flux motor is becoming a mainstream motor as on today.
Okay.
And more electric motorcycle manufacturers in the Western world are moving towards axial flex. So that means it is not an in-wheel motor; it is a center motor driven through a belt and pulley. So that is in terms of two-wheelers. In terms of four-wheelers, what happens is in Audi they have tried with axial flex motor connecting to each wheel as an in-wheel motor, by which they are trying to achieve the overall the torque output, the drivability, and maneuverability. So that's the only purpose they are using. Otherwise, axial flex motor can also be used as a axial, a transaxial motor, and that reduces the space and reduces the overall size and dimension. So that means it can fit in any place, and because of its dimension, and you can the only motor you can use in multiple forms.
We have one question from our audience, Swapnil. He wants to know which software do we use for FEA analysis of these motors?
You can use magnet, you can use flex, or you can use any of these ANSYS software. And there is also some specialized software being available in the market. I know one of these companies from Moscow, Russia. They have developed. I don't get the name in the mind. That thing I can send you by WhatsApp or something. They have developed software specifically for axial flex FEA. I will share this offline, but there is a company, a Moscow-based company. You can also Google and see. They have a software specifically for doing FEA for axial flex.
Yes. Now I request Deepika. She has raised her hand. Please go ahead. You are actually on mute.
Yes, I basically wanted to understand and ask this question. Today we are discussing more about the motor. But Manikandan, when we talk about EV, I think it's a trend where we talk more about the batteries.
Mm-hmm.
So how importance or on what chronological order does the OEM think about the importance of motor vis-a-vis battery? So is it battery first or motor first when it comes to the mind of OEMs?
OEMs, I would say definitely battery first, because battery has got big value when compared to other parts. Right? In an electric vehicle, battery constitutes more than 35% of the value of the vehicle itself. So that's the reason why, see, when I say compared with the BMW, the differentiation factor in the vehicle, it is their engine. Right? BMW engine is the performance-wise unbeatable to any other vehicle now available in the market. But when it comes to electric era, you are thinking, where do I differentiate? I differentiate in the powertrain system, or I differentiate in the battery, right? But looking at the cost proposition, battery has got the highest cost, right? So OEMs wants to have the hold of that value with them. So that's the reason why, even including Tesla or any other company, recently even Mercedes is tied up with Blade and all that. Basically, they wanted to have the highest value proposition coming, in their control. So that's why battery is given as the focus now. But what happens is eventually the battery price comes and falls, and it becomes more a standard at one place, and the attention will certainly shift to the powertrain. So right now, yes, battery is option 1 and powertrain is option 2. But in future, powertrain become number 1 option.
That's insightful. Thank you for answering. I will now pick up questions from the audience and our attendees. So
there is a question about the controller used for axial flex motor.
Yes.
Is it similar to PMSM or a PLDC motor? Definitely not similar. because axial flux motor, the controller has an additional responsibility of switching or energizing or magnetizing the stator according to the position of the rotor. So this has got a different mechanism to control, whereas in BLDC or PMSM motor, you do either FOC control or sinusoidal control or vector control, yeah, in as a whole. So these are the control used there. So axial flex motor, definitely the control mechanism is totally different.
Yeah, we have one more question, earlier question. In cons, it is actually from Vishal. In cons, what does it mean by magnet, permanent magnet composition? What is the current type of composition? And he has asked another question, what is controllability? The online electronics that decide which electromagnet can be charged on the stator, is there a scope of improvement?
So let's first take the first one about the magnet.
Yeah, the permanent magnet composition is neodymium, LDFPB2, right? So this is the composition. So it's a rarer
Manikandan, we
magnet.
lost you in between. So could you please repeat the last sentence once again?
So neodymium is the content in electromagnet, NdFeB, right? So FeB2. So this is the rare earth magnet. These rare earth magnets are mostly available in China right now, and there is no other country producing rare earth magnets, largely in China and to an extent in Japan. And people say India also, this material is available in some of the seashores in Kerala, but there is no serious production happening in India. But right now, it is available only in China. So in terms of controllability, that is what I was saying earlier also, with respect to the magnet, the rotor position, we have to energize the coil, stator coil, according to the position of the rotor, so that it is, that the unlike cold ripples, right? So we have to create that reluctance. So to do that, we have to energize the coil, and that for that we have to build a control circuit. That's control circuit in a axial flex machine. It is always becomes part of the machine. So this is what the controllability means, and this electronic becomes part of the machine, and that is work based on the position of the rotor.
Thank you for answering that. We do have a couple of more questions, but looking at the time, I think we only have a couple of minutes left. So we need to quickly answer.
Who are the manufacturer of axial flux motors is one question. There are a lot of companies in the UK, YASA, Avid, Magnex. These are the popular companies as I can remember now. Saraca is another company. So there are a lot of companies emerging out of Europe currently, and there are a couple of companies in China also. There is nobody in India so far. I heard that the Torque Motors, they are trying to manufacture axial flex motor in India. Apart from that, I could not remember anything.
We have a question from Abhishek, who's asking what maximum torque we can generate from axial flux motor, and any relation that we are deriving, how we are getting to the maximum torque.
So the maximum torque definitely depends on the current capability and how it depends on the design. So it is purely depends on the magnet usage and the your stator winding. So these are the two factors that is deciding on that. That varies according to the design. Design to design, it might vary. There is where the real designers expertise comes into. That I cannot comment.
Yeah, one of the attendees pointed out that Saita is planning to manufacture it. Yes, the information is correct. They have already got a tie-up with Padmini, PNA, and they are actually planning to manufacture these axial
motors in India. Yes, you are right.
Yes. Correct. And one more question, I think. Do we have time for one more question, Deepika?
Yes, certainly. I mean, let's go ahead with one more question.
I think let me ask that last question, if that is okay. I just want to check with you, Manikandan sir, that which do you think is the most important aspect that is needed in Indian with the Indian automotive OEM to propel EV manufacturing in India?
No, I am not getting your question properly. Can you kind of elaborate?
Okay, I may say that do you think that the current government policies or the current ecosystem that we have in India, is it currently encouraging the automotive OEMs to get into aggressively into EV space, or is it something more is needed to really drive this industry forward?
Certainly, these what do you call that? The FAME2 policy the government of India has now, right? So the FAME2 is encouraging that EV purchase by giving subsidies to the buyers. So they give subsidies ranging from, let's say, for a two-wheeler, it is ranging from 20,000 to 45,000. Three-wheeler, it is 50,000 and above. And passenger car and commercial vehicle, there is some amount is given 1.5 lakhs, and buses they give 50 lakhs as subsidy. So these subsidies definitely on the one hand side they are giving to promote the electric vehicle purchase. And each state government is also coming out with the state government policy to minimize or nullify the tax, road tax, and the GST on by purchase of electric vehicle. And apart from that, the government of India is also installing electric vehicle charging stations at multiple places. You know that recently an order is given to Tata to implement 1,000 charges across different places. So yeah, these are the steps that the government of India is taking to improve the EV manufacturing, EV adaptation in the country. And Delhi, in fact, they are going many steps further. They even trying to promote electric bicycles by giving subsidy to buy electric bicycles. So it is in a way a lot of schemes, not only for buyers, it's also for manufacturing. You introduced PLI scheme, and also there is a lot of state subsidies for getting electric vehicle component development and the manufacturing and the people getting into this business. So there is a lot of huge avenues are there already open, and India is doing really good in that.
Thank you, Manikandan. Thank you for your time. I think now we have reached the end of the session.
Well, I have a comment here which I would like to read, and I think it has been appreciated, the webinar time and the presentation has been appreciated by our viewers here. They had a great experience and foray into the EV powerhouse, the electric motor. The Axial Flux Motor seems new to the audience, but not anymore. So great content. So thank you so much. I am not taking the name of who has written it, but thank you so much again. And we also have a request, can the PPT be shared? So yes, certainly, Anirban, the PPT will be shared. And this entire video is also available on saracasolutions.com/webinar. I would post a link of that page here on the chat room. And apart from this, I still have room for one more question. So anybody has one more question, we'll take that and we'll conclude the session.
Okay. If nobody is going to have any question, then I am ready to ask the next question. Okay.
Please.
Okay. Okay. So this is more on the general side, Manikandan, is that EV range anxiety is a myth or is it a reality? So is it really affecting the EV adaptation in India?
In my position, in my opinion, it is just a myth. Now, see, when the vehicles are when we moved from horses to vehicles, no vehicle has given more than 25-kilometer range those days. But people even went for that because they wanted to use the mobility. And today we got accustomed to big huge range and availability of this fuel refilling. So that is giving us more comfort. But if you frankly speak, any individual cannot is not driving on a day-to-day basis more than 100 to 200 kilometers a day. Even if he owns a passenger car, electric motorcycle, or whatever, or motorcycle, whatever it is. So converting this into electric for this regular usage definitely is beyond the range anxiety. Range anxiety comes only where you are making a trip which is intercity or from one city to another city, or your vacation that you make once in a year or so. These are the kind of area that we have to give deep look into, and that is the where the range anxiety really comes. Otherwise, range anxiety is just a myth or just a hype, right? So we did not have a petrol bank everywhere 100 years ago. It took 100 years to build the petrol bank in in what state it is today. So like that, the test parallelly also we have to develop the infrastructure to remove these myths from the people's mind. On the other hand side, a lot of companies also working on, instead of building the infrastructure, why not give this yeah, solve this problem using the range itself. There are now cars available which can give you a range of 1,000 kilometers per charge. So in a way, the OEMs are solving these problems by implementing effective technology to increase the battery capacity to give a long range. On the one hand side, on the other hand side, of course, we are solving it through fast charging. So if you can charge a vehicle, let's say in 5-10 minutes, at least 50% of the charge, then the problem also solved, right? So we don't have the range anxiety anymore. We get stuck, we can charge quickly. So this is another way to solve the problem, and there are a lot of companies now coming out the fast and quick charging algorithms, and that is also solving the problems. Of course, we are addressing these problems in multifold. This is really solvable. It is not unsolvable, and there are some solutions already available. When the solution is available and the problem is solvable, and it is only a myth that people have to change their mindset. That's the only solution now.
Right. Well, thank you so much for that insight, Manikandan. I think it has been insightful. So I'm leaving the room open to answer that question. Axial flux motor, is that the future of e-mobility? What do you think? Do leave your comment in the chat box below so that the session speaker and the audience here gets to know your view. With that, me, Deepika, my co-host Sayed, and our key speaker today, Manikandan, see you off today. A copy of this webinar will be available on saracasolutions.com/webinar